History. If you can answer these 10 questions correctly, you're probably a very good chemistry student. So, let's answer questions about laws in chemistry. Are you ready? Question 1. You have 5 seconds to answer this question. In an isolated system, matter can neither be created nor destroyed during an ordinary chemical change. A. Law of multiple proportion. B. Law of constant composition. C. Law of conservation of matter. D. Avogadro's law. Your time starts now. Alright, so the correct answer is law of conservation of matter. It states that matter can neither be created nor destroyed during an ordinary chemical change. But the truth is that matter can be transformed by rearrangement of electrons in atoms during chemical change, but the mass of the total mass remain constant. The total mass remain constant in an isolated system. Alright, let's move to the next question. Question 2. The volume of a fixed mass of a gas is inversely proportional to its pressure at constant temperature. Charles' law, Boyle's law, Dalton's law, Darwin's law. Your time starts now. Alright, the correct answer is Boyle's law. Boyle's law is usually written as P is inversely proportional to V, pressure is inversely proportional to volume, and sometimes we can modify this and say P is equal to K over V, where K is a constant, and then if we have like two states of pressure and volumes, like initial pressure and final pressure, initial volume and final volume, then we can say that K is equal to PV, then definitely P1 V1 will be equal to P2 V2. I'm sure you've come across this equation before. Alright, so let's go to the next question. Question 3. Are you ready? When gases react, they do so in volumes which bear simple ratios to one another and to the volumes of the products, if gaseous, provided that the temperature and pressure are kept constant. Gay-Lussac's law of combining volumes, Graham's law of diffusion, Le-Chatelier's principle, law of reciprocal proportion. Your time starts now. Alright, the correct answer is Gay-Lussac's law of combining volume. It says that when gases react, they do so in volumes which bear simple ratios to one another and to the volume of the product. What it's simply telling us is that gases react in volumes and it should be in simple ratios. For example, if hydrogen gas reacts with oxygen gas to give water vapor, gas, then the balanced equation 2H2O plus O2 gives 2H2 plus O2 gives 2H2O. This is 2 moles of hydrogen reacting with 1 mole of oxygen to give 2 moles of water, and that is equivalent to 2 volumes of hydrogen reacting with 1 volume of oxygen to give 2 volumes of water. Or we can say 2 cm cube of hydrogen react with 1 cm cube of oxygen to give 2 cm cube of water. So they react in volumes, gases react in volumes, and they must be in simple ratios to one another. Do you get that? Alright, next question. Question 4. Are you ready? The total enthalpy change of a chemical reaction is the same regardless of whether the reaction occurs in one step or multiple steps. Hooke's law, Le Chatelier's principle, Bose-Einstein law, Hess law. Your time starts now. Alright, the correct answer is Hess law. And what it's telling us is that the total enthalpy change of a reaction does not depend on the path. It does not depend on the path taken by the reaction, not depend on the path taken by the reaction. So whether the reaction occurs in one step or multiple steps, the total enthalpy of a chemical reaction is the same. Alright, on to the next question. Question 5. Two electrons in the same orbital cannot have the same value for the spin quantum number. Hund's rule, Pauli exclusion principle, Hauff-Bau principle, Graham's law. Your time starts now. Alright, the correct answer is Pauli exclusion principle. It tells us that if you have two electrons in the same orbital, let's say this is an s orbital, and you have two electrons in this orbital, even though they have the same principal quantum number, the same angular momentum quantum number, and the same magnetic quantum number, they must have different spin quantum number. So if one spin up, the other electron should spin down. They must have different spin quantum number. So which means that the same electron cannot have the same value for all the four quantum numbers. Alright, on to the next question. Question 6. When an external constraint such as a change in concentration, pressure, or temperature is added to a system at equilibrium, the equilibrium position will shift to a direction that annuls or neutralizes the change. Le-Chatelier's principle, Hund's rule, Faraday's law, equipartition theorem. Your time starts now. Alright, the correct answer is Le-Chatelier's principle. It tells us that if we have a system at equilibrium, so if you impose any change in constraint on that system, the equilibrium position will shift to a direction, whether forward direction or backward direction, in order to neutralize the change. Next question. Question 7. When a hydrogen halide such as HCl, HBr, or HI adds to an asymmetric alkene, the hydrogen atom attached to the carbon atom with more hydrogen atoms already bonded to it. Markovnikov principle, Hund's rule, Huckel's rule, equipartition theorem. Your time starts now. Alright, the correct answer is Markovnikov's rule, also called Markovnikov's principle. It tells us that if you have an asymmetric alkene, maybe you have like propane, maybe you have something like this, propane, and then you perform an addition reaction plus, let's say, HCl. Then when this HCl adds to propane, or let's say propane, the hydrogen atom will prefer to go to that carbon atom that already has more hydrogen atom. If you look at these two carbon atoms, this has one hydrogen atom, this has two hydrogen atoms. So this hydrogen atom from HCl will prefer to go to the one with more hydrogen atoms. So it would prefer to go to this hydrogen atom. And then the chloride will prefer to go to the other one. So the product is going to be something like CH3, CHCl, CH3. Do you get? Alright, that is Markovnikov's rule. Next question. Question 8. The mass of a substance discharged, deposited, or liberated during electrolysis is directly proportional to the quantity of electricity passed through the electrolyte. Faraday's first law of electrolysis, Faraday's second law of electrolysis, Le Chatelier's principle, Avogadro's hypothesis. Your time starts now. Alright, the correct answer is Faraday's first law of electrolysis. Yeah, it's just a simple and direct law. Next question. Question 9. At 0 Kelvin, the entropy of a perfect crystal approaches 0. Zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, third law of thermodynamics. Your time starts now. Alright, the correct answer is third law of thermodynamics. States that at 0 Kelvin, the entropy of a perfect crystal approaches 0. We all know that entropy is the degree of disorderliness or randomness of a system. But at 0 Kelvin, the disorderliness of a perfect crystal, we can say there is no disorderliness in a perfect crystal at 0 Kelvin. So the entropy approaches 0 at 0 Kelvin. That is the third law of thermodynamics. The last question, question 10. For a system in thermal equilibrium at a temperature T, the total thermal energy is shared equally among all of its active degrees of freedom. Bose-Einstein approximation, Heisenberg uncertainty principle, equipartition theorem, Huckel's rule. Your time starts now. Alright, the correct answer is equipartition theorem. It states that if you have a system in thermal equilibrium at temperature T, the total thermal energy is shared equally among all of its active degrees of freedom. And okay, it's just a straightforward theorem. For example, if the thermal energy is let's say U is equal to, it's like half kb T, where kb is like the Boltzmann's constant. Then if you, for example, have 3 degrees of freedom, then your total thermal energy is going to be like 3 multiplied by 1 over 2 kbt, which is will be equal to 3 over 2 kbt. So it's going to be shared equally among all of its active degrees of freedom. On to the next. Alright, this is actually the last question. Let me know in the comment section how many questions you got right, and let me know if you need further explanation about any of the laws we've discussed so far. Now I have a bonus question for you that you can add to your previous score. Bonus question. It is impossible to accurately measure both the position and momentum of a quantum particle simultaneously. This superposition principle, uncertainty principle, Pauli anti-symmetric principle, first law of thermodynamics. Your time starts now. Alright, the correct answer is uncertainty principle, fully known as Heisenberg uncertainty principle. It states that you cannot accurately determine the position and momentum of a quantum particle at the same time. Mathematically, it's written as the change in position, the product of the change in position and the change in momentum is greater than or equal to reduced Planck's constant over 2. And we all know that reduced Planck's constant is equal to Planck's constant over 2 pi. So if we substitute this into the equation, the product of the change in momentum and the change in position and the product of the change in momentum will be greater than or equal to Planck's constant over 4 pi. This is Heisenberg uncertainty principle. Thank you for watching. Let me know your total score in the comment section. If you like this video, don't forget to like, share and subscribe to our channel. Kindly